It's the end of the third week in June 2025. We went from learning about International Dark Sky Week to quantum computing potentially leading the way forward for cancer and other medical research, before learning about AI beating traditional weather forecasting on the longer term. Let's take you on a deep dive. For thousands of years, Australians have been looking up at our stars, observing and interpreting star positions for their daily life. Today, Australia has one of the world's highest rates of light pollution per person. However, as part of International Dark Sky Week, Dark Sky International is encouraging governments and institutions around the world to demonstrate their commitment to helping to protect our heritage of dark skies and promote community-friendly lighting. This year, a record number of official statements have been recorded to that end. The Dark Sky proclamations issued by governments and institutions mark one small step in a broader journey of night sky protection. They aim to engage local leaders, raise awareness and spark conversations about light pollution. 2025 marks the third year that Astrotourism WA has invited local governments in Western Australia and Western Australia's regional tourism organisations to proclaim International Dark Sky Week. This year's result was a huge success as Australia achieved more accepted proclamations than any other region outside of the United States. Founder and CEO of Astrotourism WA, Carol Redford, is beaming into Talk and Science this week and will explain why WA is the best spot in the world for viewing the night sky.
It's just so good. It's because we're quite unique. Well, we are unique in the globe or on our planet Earth. Perth is very isolated. In fact, it's the most isolated capital city in the world that is on a continent. So all of our light pollution is basically concentrated in this one tiny little space in our beautiful big state. It means that we've got just, millions of square kilometres of dark sky out there that is really good, very attractive for astrophotographers and people with telescopes to come and look at the southern hemisphere night sky. But it's very important that we take these steps to protect it, to make sure that we control light pollution and make sure our asset is beautiful for the years to come.
Chris Antonio also joins us for that deep dive. He's the president of the Shire of Northam, who also said they were pleased to support Astrotourism WA and Dark Sky Week because the initiative not only highlights the importance of preserving our natural nightscapes, but also showcases the unique opportunities for stargazing and astrophotography that their region offers.
So we're going to be part of this because we are one of the places of the state that doesn't have a lot of light pollution, and just our location, and we've got clear skies most of the time. So every time Carol and the team come out, we put on a good show. We've got that. But then also what we've got is we've got the local Balladong history. So there's up to $60,000 years of history there. So not only do we get the European version of the stars and the constellations, we also get the Balladong history, and that adds another layer. So it's good for everyone to come along. So you've got local and tourists alike, and there's a lot of people that are in favour. And I noticed that some of the photos you've been showing are from locations around Northam. So it just shows you how good it is. And it's good to be part of this. It's a worthwhile project. Not a lot of light pollution, and everyone can enjoy it. And I don't think our lighting situation is going to get too much worse. As Carol said, most of the light pollution in the state is concentrated in the city. So we will always provide a good location. And like exactly where I am, on a farm just out of town, the light pollution's even less, and so it's even better to get astrophotography.
International researchers have predicted gravitational waves produced by two black holes with what an associated editorial has called landmark precision. They tackled the two-body problem, looking at how to predict the relative motion of two massive objects interacting through gravity by using techniques originally developed in the field of particle physics through perturbation theory, which starts with solving a simple approximation to a problem and then solving more complex details incrementally. The team produced results which are a highly precise analytical solution. As traditional ways to predict these interactions are expensive and slow, this new approach paves the way for future observations and more accurate gravitational wave models. In an accompanying news and views commentary, Zhengwen Liu describes the model presented by Jan Plefka and colleagues as having landmark precision. Their high-precision results will drive the development of even more accurate models of gravitational waves. These will be crucial to interpreting observations from future gravitational wave experiments, such as the Einstein telescope in Europe and the space-based laser interferometer space antenna, Liu writes. Creating new drugs or medical treatments are some of the great promises of quantum computing. Scientists at the University of Sydney have, for the first time, used a quantum computer to simulate the chemical dynamics of real compounds, a vital step towards modelling for more complex molecules and designing bespoke chemicals that could lead to an improved sunscreen or skin cancer treatments, for example. The innovative work of Professor Ivan Kassel and Physics Horizon Fellow, my autocue could be wrong, Dr. Tingri Tan leverages a novel, highly resource-efficient encoding scheme implemented on a trapped ion quantum computer in the University of Sydney Nanoscience Hub, with implications that could help transform medicine, energy, and materials science. Until now, quantum computers have been limited to calculating static properties of molecules, such as their energies, leaving the dynamic, time-evolving processes largely inaccessible given their complexity. However, this research pushes the frontier by simulating how molecules behave when excited by light, a process involving ultra-fast electronic and vibrational changes that classical computers struggle to model accurately or efficiently. This development holds great promise for understanding a wide array of light-driven chemical phenomena. Applications range from photosynthesis and DNA damage caused by UV radiation to advanced medical therapies like photodynamic therapy for cancers or skin disorders and sunscreens. For instance, a better grasp of ultra-fast photo-induced processes could accelerate the discovery of new drugs, improve the design of energy-efficient solar cells, and contribute to the development of innovative photoactive materials. A Microsoft artificial intelligence called Aurora can outperform existing Earth system forecasts, according to international scientists. Earth system forecasts, which predict a range of different things, including weather, air quality, ocean currents, sea ice, and hurricanes, are used to provide early warnings of extreme events. Existing methods analyze decades worth of data and require a huge amount of computing power. That data has been fed into Aurora, and the researchers say the AI outperformed 7 forecasting centres in predicting the route of cyclones 5 days into the future in 100% of cases and in 92% of 10-day weather forecasts. Training Aurora took around 2 months, whereas existing methods can take years. However, it was only possible to train the AI so quickly because the data used to train it had already been collected by existing Earth forecasting centres, the researchers say. Perdicaris and colleagues note that Aurora is a foundation model for the Earth system and could be adapted for uses beyond weather forecasting. They conclude by saying that Aurora represents a development in efficient Earth system forecasting and highlights the potential of AI technology to provide wider access to weather and climate information. Astronomers have found that it is not how much gas a galaxy has, but where that gas is located that determines whether new stars form. Using CSIRO's ASCAP radio telescope, researchers explored the gas distribution in about 1,000 galaxies as part of the Wallaby survey. Lead author Sionna Lee, a PhD student at the University of Western Australia node for the International Centre of Radio Astronomy Research, said the findings give new insights into how stars are born from gas. While earlier surveys could only map the gas distribution in a few hundred galaxies, the Wallaby survey has successfully mapped the atomic hydrogen gas in a significantly larger sample of galaxies. The survey revealed that having more gas in a galaxy does not automatically mean it will create more stars. Instead, galaxies that are forming stars usually have a higher concentration of gas in the areas where the stars reside. Senior Principal Research Fellow at ICRA, Professor Barbara Cantilena, who co-leads the Wallaby survey, said atomic hydrogen gas is the essential ingredient for making stars in the same way that flour is to make a cake. The research showed that being able to conduct more detailed radio observations is key to helping scientists understand how galaxies grow and change over time. The team looked at radio waves and visible light from nearby galaxies to determine the amount of gas in the parts of the galaxy where stars are being born. Daily science and space stories with an Aussie flair, plus a deep dive into the science or space headline of the week and the occasional science fiction podcast. Like, follow and subscribe for more. Membership available to help us do more, thetrek.zone/support. This is Trekzone's Talking Science.